And I found another community. I went on a call last Friday, and it's a really nice neighborhood, right up like Irvine, border of Irvine, Newport Coast, and another really nice condominium complex, higher end. Some of the issues I'm having is that some of these communities aren't, I don't know how else to put it, but they don't have means financially. So that's what I'm running into. I'm running into a situation where, I go on a call and they need a new system, and it's all about the price, and it's not exactly who we are, as you've seen some of the houses we're in, so it's not always a good fit. So what I'm trying to do is find the communities that are a little bit more upper end. So I'm finding out that these systems are becoming actually more and more popular. Because of the fact that you don't have to run gas to them. Okay, you don't have to run a vent through the roof for them, right? So really, what they have is they have one water heater, and that's it. So when I was on Friday, they had a power vent. So they're they have PVC vent, basically ABS, PVC, whatever. Either one of us allowed, but it's a water heater without a steel vent. They power vent them. Okay, and and then that way that's a cost thing too. But the water heaters are a little bit more high recovery. They're expensive. Those water heaters, really expensive. So, and this is typically, so I went there because he wanted an exhaust fan for his whole house exhaust, for his 1,400 square feet house, right? So I went there to bid that, and I climbed into the attic, and I'm like, holy crap, it's a hydronic unit. I would have had no idea, had I not climbed into the attic. And then, so I mentioned to him, because he mentioned something about, oh, that's the hydronic unit, and I go, yeah, I know, I work on those, and he was like, oh, you do? So right away, it's obvious, same story, you can't find people who work on them. And he goes, yeah, mine's not working right now, and I go, well, what do you mean it's not working? And same story again, oh, I had a plumber out and replaced my water heater, and now it doesn't work. Okay, so that's a very, very, I can't tell you how many times I've heard that. And I explained to him, I said, well, I said, probably not that significant of a problem. It's probably a minor problem, and I was late to another appointment, so I have to reschedule to come back and take a look at that for you. But, I basically told him it'd be about $89 to come flush it out and get it up and running, because it's probably just air, right? So I started thinking about, what are some of the other issues that we're having with these. And one of the biggest issues is the check valves. And so what happens with the check valves is there's two types of check valves. There's a swing check, so that is like a flapper. So when it senses flow, it opens up. And then as the flow stops, it falls back down again. And then you have the spring check, which is, it's basically a valve that's tied into the pipe. And as water passes through it, the pressure's greater than this, it overcomes the spring tension, and it allows water to flow through. So these are kind of restrictions too in the system. So I've been kind of thinking about what happens is you go out there, and these things scale up, by the way, a lot. They get a lot of scale built up on them. And so what happens is either the spring checks are no longer moving, or the swing check is no longer moving. So they become essentially inoperable. And I started thinking about, what would be a good solution to this problem, because basically we have to come out every year at the beginning of the season and service the unit, maybe even take I was thinking about putting unions on the check valves and then take them out and descale them with a little bit of acid, the pool acid, muriatic acid. Because that would take care of that issue for a while, and then they would scale up again, and you gotta do the same thing again next year. So it's not a permanent solution. So I started thinking about, well, what would be a better solution, like redesign the whole thing, like start over. Like, how would I design this if I was gonna design a system? And I started thinking to myself, what would be really good is, and this would kind of help with the air issue too, is if we had an automatic shutoff valve on both the supply and return, right? Where instead of where the water heater, where it tees off. See if this is good here. So you have your water heater here, and then you have your line in and your line out. With a hydronic system, you have a T here and here. And this is water going this way, and this is water returning this way. So normally we put shut-off valves here so that we can go upstairs and work on the system, which is the coil here. And then that way they can still have hot water to the house, the cold's still going in, and because we put a shut-off here and here. So what I was thinking is, what if we put shut-offs here that closed every time they were done being used? And that'll work on some of the systems, and I'll explain how. So a lot of the new technology, for flood safety and things like that, they have laundry lines that shut off after every use. Every time you're done with your wash machine, the valves automatically turn off. Okay, so, and it kind of communicates with the wash machine, kind of a thing. Through the electrical circuit, it checks the amp draw. So once there's amp draw going to the wash machine, it triggers a switch, and then the valves open up and allows water into the system. And what that does is it takes pressure off the hoses so that a hose can never burst, right? Because there's never water to it unless it's being used. So I was thinking the same thing here. What if we were able to shut off here and here after every use, so that these would be normally closed valves. For those of you who don't know what that means, is you have an option in electronics to have something normally open and normally closed. And there's a couple different ways you can wire this, and it's pretty simple with thermostat wire. Because a lot of these solenoid valves are what drive this, are 24 volts. So what it would do is this, and here's my theory, is that if we shut this off every time, and the plumber comes and changes the water heater, how much air is going to get up there? Very little, right? And probably enough for the pump to overcome that air pocket, because that's the issue, is once you get air in these lines, the pump can't pump anymore. It can't move air. So it just sits there, it cavitates, and then, by the way, the pump gets hot, super hot, and a lot of times they burn up. And those are, pump that goes on these are at least $900 to start. So what I'm going to do is investigate what we can do here to have those valves there, so that we can keep if we can offer a solution to, hey, this is a permanent solution to the problems you're having. There's no more check valve in the system, by the way, right? You don't need one, right? Because you're shutting off the water. And the reason, so you plumbers know, and the HVAC guys know, the reason you need a check valve is because one of the largest complaints is, hey, those guys, they came out, they put in a water heater, and now I'm not getting any hot water, okay? And the reason for that is
when they go to run hot water, the flow reverses here. They start to pull cold water backwards, okay? And then it mixes with the hot, and then you get mixed water, lukewarm, sometimes just cold water. And it's really weird. Sometimes it'll just happen at one fixture or multiple fixtures throughout the house, but it's because of the check valve. And that's why they have the check valves in the first place, is so we don't get any crossover. Because when you look at this is a physical connection right here between the hot and the cold, right? And just like a shower valve is a physical connection between the hot and the cold. But, you know, it's always a possibility for this to backflow, unlike a shower. I had this happen before. Same thing happened with recirc loops, right? We put in check valves on recirc loops, and the reason we put in check valves on recirc loops is because what will happen is, so you know what a recirc is. So this goes all the way around the house, right? And it comes back into the water heater at the bottom. And you'll have a pump here, and the direction is this way, okay? So what happens is you get, you know, you're running hot water to all these fixtures throughout the house, right? And then it returns, so you're pulling hot water through here, constantly circulating hot water through this loop, so that when somebody turns on a shower or a faucet or the dishwasher or the wash machine, they have instant hot water. They're not waiting 20 minutes for hot water, right? Because it's always in this loop. Or, you know, based on if you have a timer and all that. So that's why people have recirc loops. So what happens is the check valve will fail, stuck open, right? And so what happens is when somebody turns on a faucet, say here, the path of least resistance is here. So what happens is the water starts to flow this direction, right? Now, the water in the bottom of a water heater, because it has a dip tube, right, and hot water rises, the water down here is tepid. It's, you know, and that's where your burner is. Your burner's right here, and it's heating the water, but all that hot water rises. So what's 120 degrees up here might be 80 down here, okay? So, and that's just physics. You can't fix that. And that's why they have the dip tube down here, so that you don't mix cold with hot up here. That's the whole point of that, so that cold water stays down here always. So when this faucet is turned on and the check valve is bad, it will flow through there. And that's what happens. People get, you know, weird things happening like that. So, and that's what we're trying to avoid, is this backflow, this wrong direction of water. So I'm going to put together a good drawing for you guys so that you can see the way the plumbing system should be, so that when you roll on these calls, you're not going to be confused about where things should be placed. And not just the option to do this, but also just the way the system's designed when you get there. The other day, as an example, I was on a water heater, hydronic call, and here's what happened. They put the check valve right here, okay? I think the ball valve was right here, and the hose bib was right here, right? So what was happening is we'd go to flush this, right? So I'd hook up the hose and I'd shut this off, right? And I would pull water from here to here and out here. But I never got to pull water through the check valve. So the check valve tends to seize up, because when you're flushing a water heater and let's just say the check valve was here instead, I would be pulling water through that check valve, and that would ungum it. That would probably be enough force, you know, the 60 psi or whatever, to overcome any scale that might have built up. And it might also, you know, descale the unit a little bit as well, you know, as you're running the water through it. So this one here, you know, I recognized right away, and I said, well, and they had unions on it because they have to take it apart every year. You know, and I'm like, you know, that's not really the good thing to do here. I said the good thing to do is, and this was replumbed recently. You know, like this plumber came out and he put all this together and put unions on it so they could keep servicing it. And I'm like, well, you know, you got to get. You're getting air into the system anyway, you gotta flush it. But the bad part is when you flush it, you're not cleaning the check valve. So the check valve really should be above the hose bib, just above it, so that you're pulling water through it. And then your shutoff's here, so I don't pull any water through the cold. I'm just pulling hot, right through there, okay? So, again, I got a guy that's coming here today, and we're gonna hire one way or another. We're gonna find somebody. What I've been doing is when I get flyers on my door, I call the people who are on the flyer and I say, hey, who do you use to distribute your flyers? So
Really?
right? I mean, that's
Really?
the best way to find out who does this for a living, right? So I'm going to start doing that more often. I've got like 6 or 7 pieces in my bag right now, people I need to call to see who it is.
Oh, wow.
But I got this one cat coming over today. We talked about it yesterday. I sent him the list of condominium complexes, and he was kind of like, wow, he's sort of, I think he's Polish, from Poland. Because I was looking at his name and I'm like, yeah, his voice and all that, I'm pretty familiar. But he said, yeah, that's kind of weird. We don't really do that, but if you can cluster them in one area, then we can do it for you. So in other words, he doesn't want to drive 20 miles from one condominium complex to another. He wants to be in a cluster zone where he can hit several of them, and then and then charge accordingly. So whatever. But he's coming here today, and we're going to keep interviewing people so that we can. It's a very cost-effective way of marketing for us, and we're going to keep doing that until the board is full. And in our business on the HVAC side, for those of you plumbers who don't know, because of where we're located, waiting for the phone to ring is a bad idea. You'll go out of business. Waiting for it to get hot or waiting for it to go cold. Good example of that was last summer. It was a terrible summer for air conditioning. So we have to approach the marketplace a little bit different. So a lot of these HVAC companies, they're in Riverside or they're up north. And the reason, because it's hotter there. It's 10 degrees hotter or 10 degrees colder, oftentimes even more, and it's pretty consistent year round. But even they, because I know a lot of people who own companies and work up that way, were telling me what a terrible summer they had, even though it was in over 100 degrees. Oftentimes it just call volumes sucked. And we didn't do too bad because we weren't relying on the weather, So this is another way to not rely on the weather, because we know there's a need. We know there's nobody really does this, and we're able to. So that's why I want to get both the plumbing guys and the HVAC guys really schooled up on this. So we're gonna dial it down to where we're known in South Orange County as, or all of Orange County for that matter, as the hydronic specialists. I've already got a letter over to First Company asking them if they're able to share with me where some of these communities are, because I was really, I can't tell you how many times I've driven by that community, and I had no idea, never been in that community before.
And they're real nice.
Wow.
So, but, you know, it's a great way, to get a customer. And then on the other side of that coin, they have air conditioners, you know, so it's not just heating calls that we get, it's air conditioning calls as well in the summer, because, hey, they're the guys that know how to work on this system, right? And we become kind of exclusive to that. And then people just continue to call us and that's been our experience, as much as we've been doing this, is because it's one of the reasons why, you know, the list that we have of over 25 communities, the reason we have that list is that's all I did is put into Service Titan hydronics, and it pulled the list up of all the calls we ever ran. Then on hydronics, right? And then I went through the list and I started labeling the neighborhood, right? Which community is this? And then we found out the community name of that community, et cetera, et cetera. So now we know on each flyer what the name of the community is and how many communities we have. So we're gonna pick and choose kind of the wealthier ones. Probably more of our effort is gonna be in the Newport Coast, Irvine area first. That's probably where we're gonna hit it hard, you know, because, you know, people there have means. So yeah, we have one community that is, it's on, I want to say Jamboree, and I think these are 4-story buildings, and I'm pretty sure Bernard's has been in, and they have the hydronics typically in the ceiling, and these are condos. High-rise condos. And we met also, by the way, one of our customers, Scott, forgot his last name, over at the Foothill Ranch properties, the vineyards. He is an architect who designs homes with hydronics in them.
Oh, damn.
Yeah.
Really?
And he was like, dude, he's pointing to like the map, they're over here, they're over here.
Wow.
Yeah. So it's just a matter of finding the right person, then target focusing on marketing on these things, and then just hit it, you know,
Sounds like a damn.
hit it hard, so.
Have you tried like the college students? Like,
You know, that's a good idea, that's
cause I see them, like the UCI kids, I see them do things like that a lot.
Yeah,
and-
because it's a really good way to make decent money, you know. I can tell you, some of the companies I've talked to thus far are, you know, pretty expensive. So I'm hoping, because this guy, I got referred to 3 or 4 times from 3 or 4 different flyers.
Oh.
So I'm thinking, okay, this guy's probably got his shit together, and, you know, he's probably maybe a good find. But I think that's a really good idea, because, you know, college kids, because let's think about it, they have a schedule, and their schedule doesn't fit, you know, a typical work a day, right?
Yeah.
You know, and they need something to do part-time and when they can't, you know.
Sometimes they have winter break, they have this
Yeah,
little like breaks
right.
in between.
Right, not only that, in between, you
So
know.
I've seen them, I actually seen them. I have
Yeah,
a few
so
friends that do
it's
that.
hard finding work for them often because of their school schedule, you know. So, and this is a pretty good paying job that, you know, so yeah, I think that's good. Maybe we can throw something up at, because I'm sure they have like digital job postings that are probably free, I would imagine.
Yeah.
I haven't been to school in a while.
No,
Yeah.
sure.
Yeah, I would think so. I mean, I
Yeah.
remember before, you know, you'd have to go there and write something and stick it on a board. Yeah, so I think we're past that.
Yeah.
Anyway, any
Not so
questions?
much.
Yeah, no?
Yeah, no, they still stick one on the board.
Yeah?
Yeah.
Really?
Still, huh?
Yeah.
Okay, so I haven't been to the
Yeah, I
college
guess I
campus.
was
Little
super
pull-outs.
into the UCI.
Yeah, the little tear-offs, yeah, I guess, you know, I guess.
Shoot, let's go to the campus, I'll put some flyers up.
Yeah, yeah, I mean, yeah, that's all we gotta do
Yeah.
is do what he just said is, you know, cause I see that all the time when I go into you know, supply houses. You know, I'll see jobs posted with a little tear off number, you know, I'm like, really?
I see in it.
You guys all have phones, like, take a freaking picture.
Yeah, I know, right?
You know?
I still see in LA. like-
Yeah, it's kind of very old school.
Yeah.
But, hey.
Junior college students are probably a little bit more in need.
Yeah,
Or even Saddleback.
kind of like Saddleback
Yeah.
is probably the perfect
IBC.
campus for us, because, you know, a lot of our communities are down that way. Yeah, so. And the neat thing about this is once you get into those communities, you're recognized, so there's a lot of branding that takes place. You know, oh yeah, I've seen your trucks in here before, and yeah. So we'll eventually we'll get to know people on the board and stuff like that as well, because they live in those communities and they will get those flyers.
Yeah.
And they do have the problem, so you know, that's, I've already talked to some people that are on the boards, and when, you know, when I go into these homes and they're like, oh yeah, we can't find anybody to work on this crap, you know. We hate these things, you know. And they hate them because, why? Because they're a nuisance, they're constant maintenance issues. So if we come up with a plan, you know, how would you like to do
Yeah.
500 of these? You know, like, hey, why don't we just give us a good price and do them all? You know, that can happen, right?
Yeah.
So that's why I really want to
Tackling this down.
niche focus on something. So I kind of picked this since it seems to work. Anyway.
Sounds like a plan.
Well, yeah, Kevin, what about also doing like since you're gonna have remote valves anyway, you can do a water cop on it also.
Water cop, yeah.
Something similar,
Oh,
at
what?
least a water.
Yeah, those are, you know, those are a little pricier. I'm looking for affordability.
Well, yeah, you could do
Um,
just the wet switch, you know, that puck that they sell for us to put in the secondary pan?
Yeah,
That all it does is break a signal, so if it doesn't get a signal to open, it's not gonna open.
right.
Or if it opens, it triggers the valve to close.
Right, yeah, you could have, what he's talking about is, you have these little sensors that are cheap. And what they do is they detect water. So there's two contacts. Best way I could describe that is this. It's a flat thing with a contact here and a contact here, and wire in and wire out, right? And water, as it comes on the ground, it makes contact here. And when these two make contact, either alarm goes off or it'll allow a voltage signal to come through, and it sends a signal somewhere to shut off something. You know? So yeah, they have those on the wash machines as well. They have if you detect water on the floor, it'll shut the hot and cold off to the wash machine, and actually shut the power off to the wash machine as well.
Oh,
It's pretty cool. Yeah, it's constant work to keep up with this stuff. Like every time I turn around, there's new products in the marketplace, which is awesome. I mean, because it's all, you know, it's all something else for us to offer our homeowners and keep them from flooding out, you know, because God knows that happens way too often. Yeah.
So just to recap, the job of the function of the check valve is to make sure that it recirculates?
No, it doesn't,
Or
it just
what?
keeps it from circulating the wrong direction.
Oh, okay.
That's all it does.
Okay.
It just stops things from flowing the wrong direction.
Okay.
So the pump is usually not on, and when you have these types of failures, so there's no resistance, because the pump, you know, creates this flow. When the pump shuts off, the flow can reverse when somebody turns on a faucet, which is very common, I'm finding, in these systems that people are having problems with. So, as long as we come up with a affordable solution, a permanent affordable solution. So, you know, maybe throw in a guarantee, something like, hey, you know, if the system doesn't come on, we'll come out for free. And we'll perform a diagnostic if you purchase this, you know, right?
Yeah.
And because they're used to paying money every year. Yeah, my heater doesn't work, shit. I think I'm just gonna get an electric heater, and people start plugging in electric heaters around their house and just like give up. Yeah, I see that a lot.
Really?
Yeah.
That's great.
Yeah, and this guy, you know, that I was seeing, you know, they had money, they were looking at spending a couple thousand for a whole house exhaust fan. And he goes, yeah, my heater doesn't work. And he was like, yeah, I'm just, you know, I'm over it. It's like, kind of just throwing in the towel. That's what
Air
you're
in the line
finding.
and a bad pump.
What's that?
Air in the line and a bad pump.
It could be both. It could be one.
That's just the most common things that I've seen when I go to these calls. They're like, oh, my heater doesn't work. You flush it, and then all of a sudden, you removed all the air and everything's working again.
Yeah, by the way, the Grunfus pumps, you know how they have that little silver kind of quarter nickel shaped dial in the front, and you can unscrew that cap? The rotor is right behind that, and it spins. And you can take a screwdriver, stick it in there if the rotor gets stuck, and you can manually turn that rotor and unstick it. And they actually recommend that, the manufacturer of the pump does. So you can unstick those pumps sometimes and especially when they're turned on, because you can sort of see, like when you turn on a pump, that's a good way to diagnose to see if it's moving. I stick my little pinky in there to see if I can feel that rotor moving. It's a little scary, but it doesn't hurt. It just kind of freaks you out a little bit, you know, because it's like sticking your finger in a little fan. But so I stick my finger in there to see if it's moving. If it's not moving, then I know I'm getting power to my pump. I'm like, okay, pump seized up. So, and I try to turn it with a screwdriver. If that doesn't work, it's time for a new pump, right? It's pretty simple diagnostic.
Yeah.
You can't do that on the Tacos, only on the Grunfus. So. And the other thing to look for, by the way, we're finding that, you know, the people who change these pumps aren't knowledgeable about what they're doing. So oftentimes they're putting in pumps that they shouldn't have put in. Okay, and the reason being, just like a fan motor has a certain amount of, you know, revolutions per minute, RPM, you know, 1075 or 825 or whatever the RPM is on a fan motor, very critical, right, to how that system's going to work. So you got to match it up, right? Well, a lot of times people just put in another pump. They have no idea how many RPM that pump is. So you might have to go back to the manufacturer and say, well, which pump and what was the RPM, what was the intended use, because we don't have the original pump anymore. It's not there. And that can affect the way these heat, by the way, because you're either moving too much water or not enough water, and these systems were designed to work a certain way. And when you mess with the design, sometimes you get results that ain't so much, ain't so good. So that's it. Anything else? Questions?